Okay, now let's take a look at our geometric sequences. Okay, in order to be geometric, it means you're multiplying to get to your next term. Now, we do not say multiply or divide because we will always denote our ratio as multiplication. Okay, so always as multiplication. So again, we also have a recursive formula again. We have an explicit formula again. They look very similar. The main difference in both of them is we have an R now. And so that R stands for your ratio. What are you multiplying by to get from one term to the next? Okay, we're going to treat the recursive formula the same. The AN stays just like it is, and the AN minus 1 stays just like it is. The only thing I need to plug into that formula is what my ratio is. So here's my sequence: 2, 6, 18. So from 2 to 6 and 6 to 18, you're multiplying by 3. So then that means that my ratio is 3. Okay, so I'm going to plug in that 3. And then the AN minus 1 stays the same, and I still have to denote my first term, which is 2. And so that tells me my first term is 2 and that I'm multiplying by 3. Now I know that that's multiplying by 3 and not adding 3 because it's 3 times AN minus 1. Okay, and then let's look at your explicit formula here. So I'm going to keep the AN like it is. I still put my first term first. So the first term of the sequence is 2. Then my ratio, which is 3, to the n minus 1 power. Okay, there is no simplifying this. This is not 6 to the n minus 1. You leave it just like it is. And then if you wanted to continue further and find a specific term, so again, to find a specific term, you will always use the explicit formula. Okay. And just like in the last one, n is the number of the term you want. So if I want the 6th term, that will be A6, and then I'm going to plug in 6 for n. Okay, and then that's 2 times 3 to the 5th power. And then you may put that in your calculator, and it'll tell you that 6th term, which is 486. Okay, so that is an example of a geometric. We will do one more. So let's say I have okay, let's say I have this one. So we clearly see it's going down. Okay. And most of you would say, oh, you're dividing by 2. Okay, but we must write it in the terms of multiplication. Okay. So if you're dividing by 2, that is the same thing as multiplying by a half. Okay, if you're dividing by 3, that's the same thing as multiplying by 1/3. Dividing by 4, multiplying by 1/4. Okay, but we always have to put our geometric sequences in terms of multiplication. So this now means that my ratio is a half, not 2. So then your recursive formula would look like this. So I would put in my ratio, which is a half, times a to the n minus 1 power. I think it's power. Let me go back. Nope, not power. Bring it back down. It's a little n minus 1 at the bottom. There we go. And then my first term is 80. And so all this tells me is my first number is 80. And to go from there, I'm multiplying by a half. Okay. The explicit starts with the AN. And then I use my first term first, which is 80, times my ratio, which is a half. And this is the one that has the n minus 1 power. Okay. And so if I wanted to find, let's find the 10th term. Okay, so that means I'm going to plug in 10 for n. 80 times 1/2, 10 minus 1. So that's going to be 1/2. I meant to put a 1 here, not a 9. 10 minus 1 will be 9. So it's going to give you a very small decimal value here. So 80 times a half to the 9th power gives you 0.1, we'll just say 156. Okay, we'll just kind of round it to there and leave it there. Okay, so that gives you an example of multiplying. It gives you an example of dividing and writing it in terms of multiplication with your recursive and explicit formulas.